Edited by Khavar Jabran and Bhagirath Singh Chauhan. Copyright 2020 John Wiley Sons Ltd. Published 2020 by John Wiley Sons Ltd. Chapter 3.3.1 Introduction Cotton Gossypium species is among the important fiber crops playing a crucial role in global economy and social affairs. Cotton is grown in more than 100 countries globally and accounts for over 40% of the total world fiber and oil production. Esparza et al. 2007. Bezerer et al. 2012, and many smallholders from Latin America and Asia depend on this crop for their livelihoods. Fortucci 2002. Cotton was mainly grown in the arid and semi-arid regions during the last century. Therefore, its revival is critical to meet the increasing demand of the textile industry and accommodate the workforce for economic development on a global scale. Bezerer et al.
Hello friends, this is the just cotton introduction. The importance of cotton in this video. Please like and share and subscribe my channel.
Therefore, its revival is critical to meet the increasing demand of the textile industry and accommodate the workforce for economic development on a global scale. Bezerer et al. 2012. This revival is strongly linked with the adoption of modern technologies, especially better water management to increase water use efficiency (WUE), which is critical for the sustainable production of cotton. Cotton is tolerant to drought and heat stress, and its water requirement is less than rice, oryza sativa, maize and many other vegetable crops. The average requirement of irrigation in surface irrigated cotton is reported to be 6.7 ml/ha depending on soil, weather conditions, and seasonal rainfall. Roth et al. 2013. Planting time varies across locations depending on season and location, and the ideal soil temperature ranges between 16 and 28 degrees Celsius for better crop establishment. Cotton seedlings emerge slowly when soil temperature drops below 16 degrees Celsius. This low temperature also increases the susceptibility of seedlings to soilborne pathogens and insects. The normal depth for planting cotton seeds ranges between 2.5 and 5 centimeters depending on seedbed and weather conditions. Cotton cultivation is increasingly becoming difficult in arid regions due to low and irregular precipitation. It is generally cultivated under irrigated systems in the arid and semi-arid regions. Roth et al. 2013 due to its high temperature and radiation requirements. Constable and Banj 2015. Pollination and fiber quality are reported to be impaired by continuous rain during flowering and boll opening stages. Seton and Basbagh 2010. However, water deficiency at critical growth water management in cotton. Abhishek Datta 1, Hayatullah 1, Zanachul Firdaus 1, Raquel Santiago Arenas 1, and Ahmed at Tier 2, 3-1 Department of Food, Agriculture and Bioresources, School of Environment, Resources and Development, Asian Institute of Technology, Pathamtani, Thailand 2 Agronomy Department, Zagazig University, Shakya, Egypt 3 Interdisciplinary Center of Energy Planning, State University of Campinas, Sao Paulo, Brazil. 48 cotton production stages can reduce productivity, necessitating the development of drought-tolerant varieties. Efforts have constantly been made by the researchers to improve WUE of cotton. Barbosa da Silva and Rao 2005. Santos et al. 2010. Bezerer et al. 2012, Ikhtiar et al. 2016 because of its contribution to the rural economy being grown as a cash crop. Sanka et al. 2014 and its superior performance over other crops. Bezerer et al. 2012, Ikhtiar et al. 2016 because of its contribution to the rural economy being grown as a cash crop. Sanka et al. 2014 and its superior performance over other crops under conditions of limited water availability. Fike et al. 2017. Better water management is not only needed for the sustainability of cotton but will also help in better utilization of water for other important crops. In the following sections, different water-efficient irrigation types and water management techniques for sustainable cotton production are discussed. 3.2 Water uptake in cotton. Water uptake of a plant depends on water loss through evapotranspiration, et that includes loss of water through soil evaporation and plant transpiration. The more ET means that more water uptake is needed. This keeps the plant canopy cool for better translocation of nutrients absorbed from the soil. The major portion of transpiration takes place through the stomata, numerous microscopic pores in the leaf and stem epidermis, which also facilitate gaseous exchange. During photosynthesis, CO2 is absorbed through the stomata and O2 is released through the same pores. The seasonal water requirement of cotton varies based on several factors that include soil characteristics and principal weather parameters such as temperature, solar radiation, relative humidity, and wind speed. Transpiration rate remains high in drier and hotter climate to keep the plants cool and to produce biomass. Air temperature, atmospheric humidity, cloudiness, or radiation and wind speed are among the major determinants of crop water demand. The amount of water which needs to be supplied to the root system is determined by soil water availability. The decrease in soil available water retards transpiration as transmission of water to the roots is reduced in the drying soil, which fails meeting the evaporative demand at the leaf surface. Crop water requirement also varies with the growth stage and is driven by the climate conditions. Critical stages where water availability must be ensured are squaring, flowering, and boll development. Square initiation and boll development are adversely affected by water deficit stress during the squaring and flowering stages. It can also impact node production, leaf growth, and boll retention and distribution. Hake and Grimes 2010. Snowden et al. 2013. The vegetative growth phase of the irrigated crop is usually longer than water-stressed plants, causing the formation of more bolls on the sympodial branches. Cotton under water stress sacrifices its vegetative growth in favor of greater fruit production. Previous research documented significant growth reduction of cotton due to water stress resulting in low yield and low quality fiber. Pettigrew 2004. Hake and Grimes 2010. For instance, plant height was reduced by 23% when irrigation was withheld from squaring to the flowering period than fully irrigated cotton. Snowden et al. 2014. This reduction in growth caused by water deficit stress could be cultivar specific. Ittier et al. 2015 reported a significant interaction between irrigation and cultivar for plant height in cotton, where the genetic background of each cultivar was believed to be responsible for this differential response. In the arid and semi-arid regions, improved WUE is a priority due to limited water resources. Preventing excess vegetative growth is important for fruit setting. Therefore, irrigation should be minimized in the early growth stages.
Thanking you friends. Have a nice day. Please like and share and subscribe to my channel.